Okay, guys, sorry I got caught up, but I will redo number 3 here so you're able to see that. We're going to same steps as number 1. We want to visualize what it's going to look like. This positive 3 in front of the x squared tells us it's going to be a facing up parabola, and we know there's going to be some horizontal and vertical shifts since we have a b value and a c value that are not 0. Okay? So, the axis of symmetry is the first step. Now, in order to find the axis of symmetry, we have to use that equation or that formula, x equals negative b over 2a. The b value is 6, so we're going to substitute 6 in for b. 2 is 2. The a value is 3, and then we're just solving this. Well, 2 times 3 is 6, so we have negative 6 over 6, which simplifies to negative 1. So the axis of symmetry is at negative 1. So if we had our parabola, we know that this line right here that goes through the vertex is at x equals negative 1, meaning that this might be our axes there. It actually probably does not fall exactly on the x-axis, but it's going to look something like that, where the y, uh, um, the x value is going to be negative 1. What we don't know is the y value of the vertex. So we have to find the vertex using that function that they gave us. So y equals 3x squared plus 6x plus 2. We know that that vertex or that turning point is going to fall where x is negative 1. We just need to find the y. So we're going to do 3 times negative 1 squared plus 6 times negative 1 plus 2. Negative 1 squared is 1, so 3 times 1 is 3. 6 times negative 1 is negative 6, and 2 is 2. When we add all of those together, we get that y equals negative 1. So the vertex is at the point x is negative 1, y is negative 1. Okay? Now, if I want, I could start graphing this so it can help me picture what everything's going to look like at negative 1, negative 1. That is right about here. Okay, so I know that I'm going to have some facing up parabola, that there's going to be reflection of my parabola along this line there, and that's my vertex. Okay, the next point we could plot is the y-intercept. The c value tells us the y-intercept. Okay, so at 0, 2, right there, that's the y-intercept. And this point can be reflected over that axis of symmetry to get negative 2, 2, right here. And that's another point on the parabola. Now let's see what we have so far using a table. We know that that middle point is at negative 1, negative 1. We know that the axis of symmetry, or the y-intercept, is at 0, negative 2, positive 2, my bad. And then if we reflected that, we went down to negative 2, positive 2. Okay, so we need to find 2 more points to get a complete see enough of our parabola. So we're just going to try to choose one other point. We could be consistent and choose negative 3 and 1, and then those should reflect perfectly over that green axis of symmetry as well. Okay, I think it's easiest to plug in the point 1. So I would do 3 times 1 squared plus 6 times 1 plus 2. 1 squared is 1, so 3 times 1 is 3, plus 6 is 9, plus 2 is 11, which means if that's reflected at negative 3, y is also equal to 11. So I have the point 1 and then 11, 8, 9, 10, 11. There we go. So 3 or 1, 11. This looks like it's a pretty fast growing parabola. And then negative 3, 11. And then I'll get my super, super narrow parabola. Okay? And that's how you graph it. Okay, I also want to do numbers 7 and 9, I believe. Yep. Okay, so for number 7, we have the equation y equals 2x plus 3. 2x squared plus 3. Otherwise, it would be linear. That would be silly. Okay, this time we don't need to graph it. They just ask us to identify the axis of symmetry in the vertex. To find the axis of symmetry, we're going to use the x equals negative b over 2a. Okay, so let's identify our a, b, and our c. The a is the coefficient of x squared, which is 2. The b is the coefficient of x. Since there is no coefficient of x, the b value is just 0. And then the c is that constant, which is 3. Okay? Now, since there's no b value, we're going to be doing 0 divided by something. Well, 0 divided by anything would just be 0. So the axis of symmetry is at x equals 0. Okay, right there on the y-axis. The next thing we have to find is the vertex. Well, if we know the axis of symmetry is at 0, then that means the x value for the vertex is at 0. Because if you remember, the parabola looks like this. The axis of symmetry goes through right here. The vertex is where the axis of symmetry and the parabola intersect right there. And of course, the axis of symmetry is at x equals 0. So we have to use that function or that formula, y equals 2x squared plus 3, and substitute 0 in. Okay? So y equals 2 times the 0 squared plus 3. 0 squared is just 0. Times 2 is still 0. So y is equal to 3. So that means the vertex is at the point 0, comma 3. And then, of course, the axis of symmetry was at x equals 0. Okay? All right, number 9. F of x equals 2x squared plus 4x minus 1. Same thing, we're going to identify the axis of symmetry and then find the vertex. The axis of symmetry is still given by x equals negative b over 2a. So let's identify our a, our b, and our c. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is 4, and c is the constant at the end, which is negative 1. Okay, when we substitute our values in there, negative, b is 4 over 2 times the a value is 2. 2 times 2 is 4, so we have negative 4 over 4, which means the axis of symmetry is at x equals negative 1. So if we had our parabola, this line right here, when it goes through the middle, would be at x equals negative 1. We want to know what the y value is also so that we can identify the vertex. So we use that equation f of x equals 2x squared plus 4x minus 1, or this function, and we want to know f of 1. We want to know where we intersect that axis of symmetry. So f of negative 1 is equal to 2 times the negative 1 squared plus 4 times negative 1 minus 1. And that would leave us with negative 1 squared is 1 times 2 is 2. Plus 4 times negative 1 is negative 4 and negative 1. When we add all of those together, negative 4 plus negative 1 is negative 5 plus 2 is negative 3. f of negative 1 equals negative 3, which means that the vertex is at the point where x is negative 1 and y is negative 3. Negative 1 comma negative 3. Okay? All right.